G'day, and welcome to another update. And it's been a few days now, several days since the last one, and we're still looking at Cyclone Oma. But now Cyclone Oma has a twin, and it's Wutip. And Wutip is actually now taken over the mantle of strongest tropical cyclone in the world at the moment. But anyway, we're going to look at both these storms and some other things. Let's start with Cyclone Oma. Let's just jump straight to the forecast, and this is the Bureau of Meteorology forecast, which has it at a Category 2 cyclone, Southern Hemisphere cyclone, which means 95 kilometers per hour winds with wind gusts of 130 kilometers per hour. And you can see the track that they have it taking is it goes down until February 23rd, remains Category 2 cyclone, and then takes a deviation to the right. Now, we're going to look at the models, and I can tell you that it is all over the place, and this is extremely uncertain situation. But let's take a look at the Joint Typhoon Warning Center as well now. This is what the Joint Typhoon Warning Center has for it, and it has the storm as a 50-knot storm, which is 92.6 kilometers per hour. Currently, and it also takes this track that goes down, remains at tropical storm strength, which is Category 2 is tropical storm strength in the cyclone, Southern Hemisphere cyclone categories, and then it takes this turn to the right. So let's look at the forecasts. Alright, let's take a look at the crazy GFS. This is the American model, and it is, I can tell you, quite bonkers, because it takes the storm and then does this. It actually looks like it's going south, but then it stops, stays in place, and stays roughly the same intensity, slight weakening, well, yeah, and then it takes it a little bit towards the north, as we saw in those track changes, and it's actually deepening it a little bit there, but then it stops it again and takes it back around to the south, and look where it's going. That's a New South Wales landfalling, what looks like a landfalling tropical storm. So that's the GFS. Let's take a look at the European Centre model. Just a quick note on timing, this is way into the future. That's 2nd of March landfall. Alright, I hope you're ready for this, because this is one of the most outrageous contrasts in model predictions I think I've ever seen. This is the European Centre for Medium Range Weather Forecasting model, and it has it in the same place as the GFS. It moves in this direction, does the turn to the north, then it takes it north, 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 and has a weakening small storm making landfall in North Queensland on 3rd of March. So just consider the distance between these two landfalls. It's totally outrageous. Anyway, let's move on to the Bureau of Meteorology's model. Alright, here is the bomb, and this is the Access Bureau of Meteorology. It's taking it in the same direction, then the storm stalls for some time. We're already at Sunday now, and then it sort of weakens it to almost very little, nothing. I mean, 1,000 millibars is almost nothing. Heads it north, it becomes a broad sort of system, and then what we have here ends. But it's looking more like the European Centre in terms of track. One of the curious things about this storm is that it was so slow moving for such a long period of time near Vanuatu and New Caledonia. So I'm just going to show that here in this 10-day loop of infrared imagery, where the reds and yellows are the deepest clouds, and you can see the storm really very, very quasi-stationary before it finally got moving, but it's still very slow. If Oma were to take that route down to New South Wales as the GFS has it, one of the questions is whether the water is actually warm enough to sustain a tropical cyclone, and we generally use 26 degrees Celsius as a bit of a cutoff, although they can occur and persist at temperatures lower than that. But anyway, 26 is rough instance, and this is showing where all of the oranges are where the sea surface temperature is at 26 degrees or higher. So you can actually see there is a plume with the East Australian current that comes down towards New South Wales. So there actually is some fairly warm water down in that region, which could potentially sustain a tropical cyclone, perhaps. And this is quite revealing too, because this is the temperature, sea surface temperature anomaly, so the difference from usual, and where it's blue and purple, that's where it's cooler than usual, and then where it's reds, it's warmer than usual. You can see the whole Tasman Sea pretty much is above normal temperatures, and you've got that current where it's warm off the New South Wales coast. But look at the big cool pool. This is because the storm was so slow moving that it churned up the water, it sapped a lot of energy, it rained, cooled the temperatures down, and actually it's probably even colder than this, but the clouds are where I think the data is still coming in on that, but it's cooled the ocean down a lot, and that's one of the reasons why it didn't get extraordinarily strong. Another thing we can look at to gauge how possibly strong or whether a tropical storm can survive is the maximum potential intensity, and that's here, and this is a estimate for how strong a tropical cyclone could be at any particular location if all the conditions were absolutely the best possible. And so you can see the minimum pressure here, and that goes down to 880 in the really warm areas, which the cyclone is not in. The cyclone is down here, and that's where the pressures, the minimum possible pressures, are a bit lower. But if we look at the categories, which is the bottom plot, then the categories actually show that on the coast of New South Wales, it could still sustain a small category 2 or 3 hurricane strength storm. That's a pretty serious storm. And in the north, if it took the other direction, there are more higher temperatures there, so it can sustain a stronger storm. But there are other aspects in the environment that look like they are going to maintain the storm at tropical storm strength, but we shall see. Intensity is a bit of a tough thing to forecast. There are, of course, a whole number of models that are run, and you can see we're pretty much, this is a whole bunch of other ones, and you can see we're good till 48 hours, and then things begin to go a bit crazy. Storms going all over the place. There is one that makes a slightly earlier landfall. That's the Hurricane Wharf. So, maybe we'll have a better idea in the next day or two about what this thing is going to do once it makes its stall. So that's Oma. I mean, it's still very uncertain, and so we're going to move on now to its twin in the northern hemisphere, the stronger Wutip, Typhoon Wutip. Here's the view of the two storms with Wutip and Oma. So let's zoom in on Wutip. So here is Typhoon Wutip. It is currently a Category 1 hurricane strength typhoon. That means that's a different category to the southern hemisphere. It's significantly stronger. It has sustained winds of 75 knots, which is 139 kilometers an hour. So it's now significantly stronger than Oma, and it is intensifying and is going to get stronger. In this loop you can make out a few islands. There are some that it has passed down here, and then up here is perhaps the main concern, which is Guam. And Guam, it looks like the typhoon will pass to the south of Guam, but let's have a check on what's going on. So here is the track from the Joint Typhoon Warning Center, and it takes it up south of Guam, as you can see, and then it turns around. It seems there's a lot of uncertainty after 3 days in the track forecast. So we'll take a look at the models. Peak intensity 105 knots, that's Category 3, would make it a super typhoon. So it's a very dangerous storm, but it does look like it is currently forecast to miss Guam, and Guam would then receive big surf and tropical storm conditions, I guess. We can do the same thing for the sea surface temperatures in the Northwest Pacific. And it is winter time for the Northern Hemisphere, so late winter. So there isn't as much warm water to play with, but it's still pretty damn warm down in the tropics. And this is the 26-degree limit. And you can see if we look for Guam, it's this thing down here. That's Guam. So Guam is, yeah, there's plenty of warm water for it to live its life in this region, and eventually it'll head off into the colder waters and die. So taking a very quick look at the models, this is the GFS, and the storm Wutip comes around 9:23. It's actually hard to see, but it's moving just to the south of Guam, but giving Guam some wind, and then it's moving up towards the other Marianas Islands. And the European Center model also takes a storm south of Guam, perhaps a little further south than the GFS. So the GFS is looking a little worse for Guam, but still neither of them predicting the center to make landfall. And here are some other models, and it's the consistency in the track when you compare with Oma, which is fairly, you can say fairly solidly that it's going to take at least up to here, this track. This outlier is very unlikely to come to be because the other models are in such good agreement. So it looks like, yeah, passing south of Guam, good news. Here's the latest from the Suomi VERS NASA polar orbiting satellite with, let's go in and have a look at Oma, with New Caledonia over there and Queensland over here, Fraser Island, and then up we travel across the equator and we're at Wutip, and there is the outline of Guam. So let's just look at a couple of other things around the globe. This is the North Atlantic, and there's been this huge storm, massive bombing, I guess it's a bomb, low pressure extratropical system, and this is Western Europe over here. But it's looks like it's heading into Greenland. Actually, it's not actually heading into Europe, but there is some a cold blast happening, so I'll just quickly show that, and then I'm going to look at the global forecast and wrap this up. So yeah, this is actually kind of interesting. There is a blast of cold air, and the blues here are snow, and this is Europe. So Western Europe, there's a area of rain and snow that comes down. It brings snow all the way down into Greece, and heavy snow in interior Greece. Now, it lasts for a while, so it's actually quite probably disruptive snow for Greece in particular. But the low actually progresses into Africa, and there, look at that, that's snowfall in Libya, I believe. So that is quite a north to south moving storm. Really quite interesting. I'm going to have a look at Africa, the Africa model region. Let's have a look at that. Yeah, the funny thing is that they don't actually plot for Africa snowfall for good reason. There isn't that much of it there, but it does snow in some areas. Anyway, so we can't see the snow, but we can see the storm system coming down, and it shows it all as rain. But some of that may be snow over some areas of Africa. We shall see. That seems like an extensive area. I mean, in the mountains, I can get that, but over a large area of Libya, northern Libya, that'd be quite impressive. Although it has snowed there, and in Cairo once it snowed as well. So yeah, that's pretty interesting. We shall see how that pans out. Keep an eye out for snow in Libya. Not entirely dissimilar is in the North America and in the United States. There is snow coming down into what looks like Nevada, Arizona, and New Mexico, and into Texas. So yeah, that's a probably quite a lot of snow really for those deserts. That's also a bit unusual, I think. And then it brings snow into the Midwest. So finishing up, just having a look at the global forecasting system 10-day forecast for the whole globe, and of course it's got that weird track of Oma, and then there's Wutip here doing its little turn and then dissipating and wandering off and falling into nothing. And ITCZ, SPCZ, lots of rain over the Amazon. Bada bing. I think that's yeah, I'm sure there's lots more going on, but that's all I got time for tonight. So have a good one, and please, if you got this far in this video, leave a comment to say hi. Thanks.